Okay, so just a quick one on integration by parts. This is what it is. So when you have a question which is in the form of a product of, let's use this one for example, you have the integral of x being multiplied by this. So in order for you to integrate this, you need to use this methods called integration by parts. So to do that, you can just pick your u and your dv, and then from your u you can get your du, and then from your v you can get your from your dv you can get your v. So now u, let me write my u here and dv here. So to pick your u, you want to pick a number which will be very easy for you to differentiate. So I know these two are easy. I can easily differentiate this. I can easily differentiate this. But once I pick this one as my u, then this one must be easy to integrate. But once I integrate this, the power will increase. So it's better for me to pick this one as my u. That means the rest of it, which is e to the power x dx, will be my dv. So from here, I can get my du by differentiating both sides. So when I differentiate this with respect to x, I'll have du dx, which is equal to 1. But we don't normally write it like this. We cross multiply and say du is equal to dx. And then from here, I can integrate both sides and say v is equal to, when you integrate this, you still get this. You don't need the c at this stage. So now we have everything we need to integrate this. So the integral of x e to the power x dx will be uv minus the integral of v du. So our u is x multiplied by our v is e to the power x, then minus, you can have your integral sign, then your v is e to the power x, and then du is the same as dx. So now it's just a matter of simplifying. When you integrate this, you get the same thing, and of course at this point you need the c. So it's this easy. And then for our second example, we can have something like this, cos x dx. So in this case, I'll let this one be my u because it's very easy to differentiate. Once I differentiate it, it will give me something like this, a 1. It's just the same as this. So I'll straight away just write it like this. So du is equal to dx. And then this will automatically be my dv. So my dv will be cos x dx. So now to get my v, I just integrate both sides. When I integrate one with respect to v, I get the v. When I integrate cos x, what I get is simply sine x. No need to put the constant term here. And then remember the rule. This is what it states. So I have my u as x, then my v as sine x, minus the integral of my v here is sine x, and then my du, this is my v, my du, where is my du? My du is simply equal to dx, which is good. And then this times this remains the same. And then when you integrate sine, you get negative cos x, and then plus some constant. Then you can simplify this and say you have x sine x, negative and negative will be positive, cos x plus c, and then you are done. So for question 3, let's have something that doesn't look like a product, but when you come to think of it, it's actually 1. So this is like a product of 1 and natural log x dx. So in this case, you can just let your u be this thing here, ln x, and then your dv will automatically be 1 dx, 1 dx like this. So I decided to choose this as my u because it's much easier to differentiate. Imagine integrating this, because that's just what we have there. So there's no way you choose this as your dv. So to differentiate this, I'll simply get, when you differentiate a natural log function, you simply get 1 over x and then dx. Remember, this was du dx, which gave us this, and then I've just cross multiplied to have that. So this is my du, which is equal to 1 over x dx. And then this side, we have dv, which is equal to dx. From here, we can get our v by integrating both sides. Fortunately for us, the integral of dv, the integral of 1 with respect to v is simply a v. The integral of 1 with respect to x is simply an x. So this is easy. So now you can use the formula u dv is equal to uv minus the integral of v du. So our u is natural log x, and then our v is x, and then minus, make sure I put this in brackets, our v here is x, and then multiplied by our du is 1 over x dx. So this and this will cancel out, then you can multiply these two so that you have x multiplied by natural log x minus the integral of, this will simply be a 1 dx, and then you can't take this one any further unless you want to write it as a power. And then minus the integral of 1 with respect to x is simply x, and then plus the constant of integration, which is a c. And then finally, we have this one here, x squared natural log x dx. So you can still follow the same procedure. Just make this one your u and your work will be much easier. So you can say let this be our u. So the moment you choose this to be your dv and say dv is equal to this, and then you try to integrate both sides, you realize that it will be very hard for you to integrate this. So it's better to let this be your u, and then everything else will be your dv. So we are remaining with x squared dx. So to get our u from here, you can, to get our du from here, you simply differentiate. Then this one will give you 1 over x dx. And then to get our v from here, you can simply integrate. So when you integrate this, you get a v. When you integrate this, you get x to the power 3, because the power will increase by 1 over 3. Of course, we have a c, but we don't need it at this stage. And then you can apply the rule. And then our u is natural log x multiplied by our v, which is x cubed over 3, then minus the integral of our v, which is x cubed over 3, multiplied by our du, which is 1 over x dx. My pen died, so now you can multiply and minus, you can reduce these, so like this. Then you can factor the 1 over 3 out, so that you have x squared dx like this. And then you have x to the power 3 over 3 natural log x, 1 over 3. When you integrate this, you get x to the power 3 over 3, and then plus the constant of integration. Then you have this times this will be 9, and then plus c, and you are done.